So welcome everybody. Hope you're having a good day. We've had some good sessions up till now. We're going to keep this kind of just easy, but want to share some information on Ventacity and what we're offering to the Passive House community, and just go over some basics on our products and some of the other things we're doing in the technology side. So what you have here is a picture of basically the applications that are different units can be applied to a full range of applications. So you've got a rooftop unit that can be on a curb or on a stand. You can put a unit next to the building on a stand. You can put units in a mechanical room. We've got units that go in ceiling plenums, inside units that are our ceiling mounted horizontal ducted units. And we also have our VS500. It's designed for classrooms, meeting rooms. We also are using them in retail spaces. And it's a ductless, very easily installed, very effective ventilation unit for larger spaces. So this is the range of products. We've got the 3000, the 1000 RT or rooftop. Again, designed for rooftop, but can be put into mechanical rooms. I'll get into some more details on these models. They're all UL, CSA listed, and many of our units are Passive House certified, and the rest of them will be. And I'll explain some of the details with that. So one of the big important factors is to understand that Passive House certification, HRVs and ERVs are different units. So the HRV is just doing heat recovery, ERV, heat and moisture recovery. And what you see here is a Passive House certificate for an ERV. And there's an extra line here. This red arrow points to the humidity recovery. If the Passive House certificate does not have humidity recovery indicated, in this case, 65% humidity recovery, then it is not a certified ERV, it's a HRV. We have certificates for both HRVs and ERVs. That's an important factor. Just as a matter of record, Passive House certified ERVs in the commercial range, which is basically 300 CFM and above. There are only a couple of Passive House certified ERVs in that commercial range, and they're all Ventacity. We are the only commercial ERVs Passive House certified in the world. We're going to be adding more of those certifications to our line very shortly. I'll get into a few little details. So as Passive House testing is shown, the most critical thing is when you look at the incoming outside air at 50 degrees and the exhaust air at 50 degrees, this exhaust temperature is the critical element. That's basically energy leaving the building. If that was leaving at 60 degrees, then you would be exhausting basically energy out of the building. So that's a critical element. And as you can see here, it's modest temperatures, but that's actually when you have a smaller delta T, having that kind of efficiency is a very strong indication of very high efficiency. All of our units come with economizing and what we call smart economizers, where what you're looking at here is a dual damper. The side damper opens and bypasses the heat exchanger. That's hard connected to a louvered damper that's over the heat exchanger. And so you can partially bypass, if it was 40 degrees outside in a classroom setting, you wouldn't want to be just bypassing 40 degrees and dumping it on a bunch of kids in a classroom. So you can partially bypass, open this up, and we do a set point in the controls where you can set a minimum delivered air temperature, and it will not allow more of that 40-degree air to bypass the core than will result in you having a 60 degrees or better temperature. So the rest of it goes through the heat exchanger, some of it goes around it, and your delivered air is at a set point. So it really optimizes the times when you can do economizing. Our rooftop HRVs, as I mentioned, even though it is a rooftop, this is a VS1000 RT model installed in a mechanical room. Here it's installed on a roof. And ideally, it's good to do a zoning approach. And we did this as an actual project that we did where four different HRVs were feeding into four different zones, where some of those zones were on demand control with CO2. Other zones were on scheduling and just continuous constant flow ventilation, constant air volume, and really makes for optimizing your designs. Our RT units come with a curved roof. The VS1000, that roof is easily removed, these 4 bolts on each end, and you can remove it if you're going into a mechanical room. If it's on the roof, it's a good idea to use that roof. The end panels on these units can be removed and put on the bottom. And so instead of down ducting on a curb right through the roof, you could side duct it. If it was on a stand, for example, or on the roof, side duct it. And that is field adjustable. So it's a real advantage for installing in different spaces and different tight configurations. The SQ series, as I mentioned, SQ for super quiet. It's 35 decibels at 500 CFM, and it's a ductless unit. So the supply air comes out of this grill. It's hung on the ceiling. Supply air comes out of this grill and runs across the ceiling with a Coanda effect. And then the return grills are at the front corners. And then on the back side, it's ducted directly. It's put at the wall and it's directly ducted outside for the supply and return. So it doesn't have any ducts to run, and very easily installed in classrooms, meeting rooms, retail spaces. So it looks like this. And so you can put them on the side wall, you can put it on the end wall of classrooms and provide very optimized ventilation. This particular model comes with a CO2 sensor installed and can do demand control in a classroom or meeting room setting very seamlessly. This is a test case we did when we actually installed on a temporary basis in a classroom in New York City, in the New York City School Construction Authority, and allowed them to test this. And it was a very easy, although nothing is easy in New York. I could, over a beer, I'll tell you all about how long it took and how many people were involved. But it was a good test and proved to be effective. This is a retrofit installation in Oregon in a school. This unit is partially up in the ceiling to reduce the footprint of it. And you can see this is an HRV with a condensate drain going right outside. That's outside. You can see the hoods for the supply and return here. Again, pretty straightforward and easy install. This is a school in Maine where we went in and took these train unit ventilators out, which were very loud, very inefficient, using hot water from the boiler system to do 100% of tempering of outside air, so using massive amounts of energy, and installed the VS500. This was a creative approach where these have an installed coil, hot water coil for doing tempering and heating of the classroom. And this duct system has got 3 dampers, which allow it to close off the outside supply and return and open a closed loop. And so what you're doing is, they call it morning warm up, where before class starts, they're bringing in outside air, or not bringing in outside air. They're just recirculating through and taking advantage of heating it with maximum capacity on the coil to warm the classroom up. And then the dampers open to the outside air, the recirc loop closes, provides ventilation, 100% outside air during school hours. Our CM, or ceiling mounted series, is 250, 400, 900, and 1200 CFM. We're working on a larger unit that could be up to 1800 to 2000 CFM. And these, again, all of these are HRVs or ERVs and installed in ceilings, in up horizontally ducted units to the outside. And we do have DX or a heat pump solution with tempering that air, or hydronic changeover coils that can just bolt right onto those units and provide heating, cooling, dehumidification. We do this quite often, DX coil and controls. I'm not going to get into too much on the details today, but we have all the support on that, and use an eco controller if needed to do some controlling and managing of humidity, temperature, so forth. So you can see this is all available on our website. You can get all of these guide sheets that explain how to install these systems. This is a DX kit. It's actually the DX kit that's sized to the 1200 CFM ceiling mounted unit, but it fits on the end of a VS 1000 unit and can be tied in. Very straightforward installation. And the CM series have been very popular. Those that are going to go on the tour on Saturday, you're going to go to Mattapan Station, where 15 of the 900 CFM ERVs are being installed, all with DX tempering included, and put it at the end of a hallway. 2 offset ducts run down the hallway, supply return to each room. No stack effect, no fire dampers and hatches between floors. Very straightforward installation. It's become a very popular way to do multi-story offices, multifamily, and so forth. And they are very popular. All right. So that's the line that we have. What I would like to do, I'm going to pop out for a second and pop back in. I'd like to share a little bit on our controls. We have an advanced controls lab, and I see there's one question in chat. I'll come back to that if that's all right. So what you see here is an actual, this is live. I'm here in Maine. This is nearby a digital print facility that's utilizing our ventilation system. And we can actually monitor exactly what's happening. And as you can see, it's only 60% efficient, but if you look at the numbers, we're not doing any real heat recovery. We're just moving air at this point because it's all within a couple of degrees. But we can monitor that efficiency. We're monitoring. They actually need to replace the return air filter. Is showing that it's red here. You can see it on the diagram as well. So the supply air filter is green and is fine. The return air filter is clogged. This is a digital print facility. So again, paper and paper dust and so forth is all a factor there. But this is VS Pro, which is our advanced controls option. And all of this is on our browser. This is IAQ Pro. And you can see where we are monitoring indoor air quality. This is at that same facility, the digital print facility that I showed you. And we have sensors inside that are providing real-time monitoring and data capture of temperature, humidity, CO2, VOCs, and PM 2.5 fine particulates. And it's all graphed, it's all digitally captured. You can see temperatures consistent. Relative humidity is very consistent. These are critical things to a digital print facility, so they're really able to monitor this. Carbon dioxide, so we've got good ventilation in the factory that's maintaining pretty much below 500 parts per million. That's 570, but call it below 600 ppm. And you can see that the trends below that over a longer period, and you can zoom in very easily and see that we had a little spike here. And it's right around noon, may well have been a lunch gathering and people in the facility. We have noticed, and this is something that's really important, we've noticed a volatile organic compounds, or VOCs, have been going all over the place. And if you look in here, you'll see pretty big spikes and cause for concern. So we are actually looking at that and monitoring that, and now try to determine what it is that those VOCs are that's causing those spikes. And then we have fine particulates, and that is in the pretty manageable range. These lower graphs are color coded. You can see it's all green, the line. That means it's all in the green. Here you've got a lot in the yellow, and some even all the way up in the red that are indicating challenges, basically, and cause for concern, and we're actually investigating what it is that's causing those. The key is that we take this in IAQ Pro. You can tie that to VS Pro, which is controlling the ventilation systems. And it's a very advanced controls and management system that allows you to manage and control and monitor indoor air quality. And actually, very shortly, we're connecting the two and be able to do demand control, not just on a CO2 sensor, but on a whole range of indoor air quality parameters, and optimize systems. All right. I think I had the chat. Somebody asked, yeah, are there limitations on the DX for the CM units depending on the airflow requirement? And that is going to be something where we do selections where we actually would take your airflow and apply a regular selection to the efficiency of the HRV or ERV, and then do a selection for the coil itself and provide you with delivered temperature, humidity at design conditions, and be able to determine how to optimize that. The other factor is when you do add coils and so forth, you add static pressure drop, resistance basically to your airflow. So you got to make sure that your systems are going to be able to deliver the amount of air you need at the static pressure that your system is set up at. So all of that is part of the engineering and design, and we support that all along the way. All right. Anybody have any questions? Throw it into the chat. Well, that's short and sweet what Ventacity is all about. We'll be at the conference in Boston. Hope we'll see a lot of you there, not all of you there, and look forward to the rest of the conference. Thank you, everybody.